Welcome back. This is Daniel Price. I'm an Associate Professor of Astrophysics at Monash University in Melbourne, Australia. And this is part 2 of an introductory tutorial to programming in modern Fortran. So where we got up to at the end of part 1 is we've got a basic Fortran program and a basic Fortran module which just contains one simple function to calculate the area of a circle based on an input radius. So the next most important thing is not so much the syntax of Fortran, but how to organize your code. So a Fortran code in general is going to consist of a series of modules, and it's good practice to have each module in a separate file. So, for example, we've got this module called geometry, which has functions related to calculating area or a volume of things. And so every new functionality we add, we're going to add to a module. So you can see quite quickly we're going to get to a series of different text files, and it's going to become laborious to get these files all together into a big program. And so whereas previously we've simply compiled this in the command line, we've already got a lot of compiler flags that you have to type and remember. We may not be able to remember all the relevant names of the modules we want to compile. We just want to simply have one program in the end called maths that compiles all of the relevant files into a single program. So there's one step I want to show you in between, which is that I can compile this geometry module independent of compiling the main program. So the way that you would do that is that you say, well, I want the output of my compilation to be geometry.o from the file called geometry, and the -c flag means I want to compile but don't link. So compiling now happens in 2 steps. So I compile my module geometry. Now in the tutorial I've called this module area, so maybe it's confusing. So we called this module geometry, but I'm going to rename this file to be area.f90, just to be consistent with what I've written in the notes. So I'm just going to rename this one area.f90. Oh, sorry, let's just try that again. Area.f90. All right, so now if I was following my notes here, this module is called area.f90. Oh yeah, so I can compile into a file called area.o. Now you notice I get 2 things. I get a file called geometry.mod and area.o. Now these are not programs, I can't run them. If I look in geometry.mod, it says it's a binary file, it's got a lot of junk in it. And similarly, area.o is some kind of unreadable file. All right, but the step goes as follows. So I'm just going to delete my program as well. So I simply have this area.f90 file, which is my module. Notice how the module name geometry becomes geometry.mod when it gets compiled by the code. And I get this area.o, which is a compiled version of the area.f90. Right, so hopefully this is not too confusing at the moment. So then I can simply compile my program the same way. So gfortran -o maths.o, and then I want to compile but do not link maths.f90. Okay, and then finally the last step would be to say gfortran -o maths.o area.o. And that would give me a program called maths that would run like before. Now you may have thought that was a bit of a long-winded way of doing this, and it is, and we would never really do that on the command line, but that's what we're going to make happen in something called a Makefile. All right, so a Makefile is again just a text file, so I'm just going to clear it here. So you can see what's in my directory at the moment. I'm going to delete all of my .o files and my .mod files because they're just temporary files. I'm also going to delete the executable file, maths, as well. So I'm just left with my 2 text files, which are called area.f90 and maths.f90. And so we're going to make a file, and we just put it in the same directory, and we call it Makefile with a capital M. And so now I have a text file which is just blank called Makefile. All right, so again, so Make is like a little mini programming language, but the purpose of Makefiles is to compile a sequence of files together to make a single executable file and to help you in that process. So the most basic kind of make script we could do is we could declare a variable called hello, and then a Makefile operates by having a target. So the target we'll just call default in this case. The next step is you must type tab. So underneath the target, so our target is called default, we type tab. So this cannot be a space. And we're going to echo, we're going to echo hello world for the moment. And that's it. So when I type make, it will go to the first target in the file, which is called default in this case, and it will execute the Unix command underneath. All right, so then I type make. So first of all, it tells me what it's going to do. So it tells me the Unix command, and then it executes the command. So simple thing, if you don't want it to tell you the command, you just put an @ before the start of the command. So I type make again, and I get hello world. Right, so the second thing is we can use these variables. So I've declared a var called hello. Well, the variable is called var, and the value is hello. It's just a string. So now I can do echo curly brackets var, and I type make, and I get hello. Right, so hopefully you get the idea. So make is just a simple kind of programming language. And so the key things in a Makefile are called targets and dependencies. All right, so I'm going to help you understand this and then help you understand why this is going to help us compile our code. So let's make another variable called var2. Let's call it world. And now we're going to have two targets. We'll call the first one we're going to call Mary. So I'm going to just change the name of default to be Mary. I'm going to make another target called fun. I'm going to hit tab, and then again echo, and that's going to echo variable 2. All right, so if we type make again, so what you'll see happen is we just execute the first target in my Makefile. So the first target simply, so the target is called Mary, but what is executed is the indented lines underneath. So we simply get, echo what's in this variable, which just simply prints hello. All right, so now we can execute the other target by giving the name. So if I just type make Mary, then again I get the result of the first target. But if I type make fun here, I'm going to get the result of the second target, which is called fun. So you can see when you type make followed by a string, that string is simply the name of the target that you want to execute. And if you type make with nothing, it simply executes the first one, which in our case is Mary. All right, so that's what a target does. Now, the good thing about Makefiles is you can have what you call dependencies. So I can say, for the target fun, I cannot run this command until it's executed the first command. So Mary is what you call a dependency of the target called fun. All right, so now if I make Mary, same thing happens before. But if I type make fun, then I get hello and I get world. Because fun depends on Mary, and that means Mary has to execute before fun can do its thing. So hopefully that's pretty clear. So that's what targets and dependencies are for in Makefiles. All right, so the final little thing is you can override these variables on the command line. So for example, you can type make var equals goodbye, and then you can execute the target fun. So for example, that would give you goodbye world, because you're replacing the value of var on the command line with goodbye instead of hello. There's a couple of other little tricks. So there's some predefined variables in Makefiles. So for example, there's a $@ symbol and there's a $input symbol, which turn out to be quite useful. So let's try the following. So I'm going to just simply print out what the $@ is and what the $input is. And when I type make fun again, now I get world is fun and merry. So fun is simply the name of the target, so that's whatever's to the left of the colon there. And merry is whatever's to the right of the colon, and that's what you call the dependency. So the $@ just simply gives me the name of what's to the left of the colon, and the $input gives me whatever's to the right of the colon. All right, and finally we can define new variables from existing variables. So we're going to use a substitution. So we're going to use var2. So we're going to declare a variable called var3, which is simply the same as var2, but I'm going to replace the substring world with the substring planet. And I'm going to make another target called hey, and I press tab. I'm going to say echo variable 3, var3. So now when we type make hey, we should simply find it's that we've got a variable where we've replaced world with planet, so we simply say echo planet, and therefore we just get the planet on the screen. All right, so that's the basics, but you can see why this might be useful, hopefully, in order to compile a code. So you don't really need to know much more about Makefiles, but that's the guts of how they work. So we can just simply type a simple Makefile for compiling sort of any Fortran code. And it's just the same kind of structure. It's just instead of these variables, we have a special variable called the name of the Fortran compiler. So that's going to be gfortran. We're going to make another variable which just has the compile time flags. Now you remember already I told you could use a few little handy hints, so we might want to turn on optimization. Remember that's an O and not a 0, minus O3. We're going to turn on compiler warnings. We're going to turn on extra warnings. And we're going to enforce that we're going to obey the Fortran 2008 standard. So those are just two variables. I'm going to have another variable which simply lists the name of all my Fortran files. So it's area.f90 and maths.f90. Now, if you remember in our history up here, then, let's go back in our history a little bit more. If you remember what we did when we compiled our code, we actually need maths.o and area.o as the final command that we type to compile the code. So we're going to compile each individual file with this command, and then we're going to link them together with this command at the end of the sequence. All right, so the first part of this means we need a new variable called obj, which is the same as the source variable, but with the extension on the file, so .f90 replaced with .o. And then we need a target. So this is a special kind of target called a default target. It means anytime I see a .o file, it depends on the corresponding file name with the .o replaced by a .f90. And so basically I'm telling the Makefile the rule for making a .o file from a .f90 file. Okay, so the rule for doing that is simply to invoke the Fortran compiler with its compile time flags and its -o. So if you go back and have a look at what we typed before, it's -o maths.o minus c maths.f90. So what I want is the thing to the left, which is the .o. So if you remember, that's the $@. And I want to -c the thing to the right, which is the $input. Okay, so that's my rule for making a .o file from a .f90 file. Now that's a special kind of rule because it's what you call a generic rule. So actually that's not the first command in my file. So the default target I'm going to call maths. And that is going to depend on having already done this file to make all the object files on this. So essentially, it's going to depend on this object, which is a list of .o files. I'm going to show you how this works in a second. And my command for linking the program together is to invoke the Fortran compiler with its flags, and I want a -o And my output name is the name of my program, which I want to be called maths in this case. And what has to happen after that is just this string which contains maths.o and area.o. Okay, and finally I'm going to give myself another just little helpful target, which is going to delete, just clean up all the temporary files that I'm going to create. It's going to delete rm.star.o, star.mod, and maths, which is my executable file. Now it's kind of helpful in a Makefile to use rm-f, so that you don't get an error if the mod files and .o files don't exist. Okay, so this is a basic Makefile, and really you can just use this as a template for any Fortran code you're going to write. And the only thing you'll need to change is the list of just the list of file names that you're going to compile. Right, so if you remember, we've just got these two files in this directory now, and we've got this Makefile. So while I've gone over the introduction to Makefiles, you don't really need to know the details. You can just borrow this kind of generic Makefile and just change the names of the source files on this command. Right, so I'm going to type make. Now you should, hopefully, if you follow what we've just done before, understand what just happened. So we've got a .o file being made from a .f90 file. There's the name of the Fortran compiler, the name of the flags. So we're obeying this rule for getting my .os from my .f90s. And so it executes fc with the name of the flags, -o, the name of the .o file, -c, the name of the .f90 file. It does that for each of my .o files, and then it compiles the code together in this link step and gives me a program called maths. All right, so in one command I simply type make, but you notice when I type it again that it knows, magically, that nothing has changed in my text files, and therefore it does not need to recompile the code. So this is one of the beautiful things about Makefiles, is if you haven't changed your code, it doesn't go and type all those commands again for you. So it saves you a lot of time. All right, and then I can run my program like I did before, and it produces the same results. So the key thing here is the Makefile is a way of organizing your code, and it's very good practice to have your code spread across these multiple files where each file essentially contains one module. So you notice in our area thing it contains the module geometry, and well, there's different conventions, but it's nice to adopt the convention, which I haven't done here. For example, it'd be nice if the name of the file was the same as the name of the module. So that's not necessary, but maybe it's a nice convention to follow. The other thing that we're really trying to achieve here, I'm just going to change my variables back to something sensible here in my maths module. We're really trying to make our program as lean as possible. So our program really should just be a driving routine, and the guts of the work is done by the subroutines in the module. All right, so in the case of this program maths, it's really a skeleton program that just gives me the output, and the guts of the work is done by a subroutine that's inside the geometry module. And good practice here is just to use this only statement. So telling us what we're importing from the module, we're importing the area function and we're importing the value of pi. So if you're familiar with Python, this is just the same as a sort of import statement. So it's like importing from a Python module. This is just importing from a Fortran module. All right, so very clever, because I didn't change anything in this area.f90 file. So the only thing that it recompiled was the maths.f90 file, and then did the final link step again to update my binary. So that's really the advantage of a Makefile. Imagine you've got a very big program, and you just change this very small part of it. It doesn't recompile the entire code just to change that small part. So you've seen if we change one of the files, it only recompiles that one file. But this could be a little bit dangerous. So for example, what if I changed my area function to take in two variables? Or what if I changed this to take in an integer parameter? So this would be allowed. But if I simply type make like it is, and I run my code, well, actually that worked fine, but it gives me the wrong answer. So you notice that I'm getting garbage out now. So because I'm sending an integer, I'm sending a real variable to an integer function. Now, Fortran should have checked this, but it didn't check it in this case because I didn't tell it that maths needed to be recompiled. So maths in this case needs to be recompiled because this area function has changed. And maths is using this area function, but it's still using the old version. So for example, if I type make clean followed by make, now I get an error which says, hang on, you're trying to pass a real to an integer. This shouldn't work. But this happened because I didn't do my what you call the dependencies correctly in the Makefile. All right, so let's change this back to a real. I just press Control Z there to undo. And make again. Now, to avoid this kind of problem, what you can do in a Makefile is specify your dependencies. So the way I would specify this dependency, I would say maths.o depends on area.o. So that is, if I change something in area.o, then I also must recompile maths.o. So the right way to do dependencies is like this. It depends on your philosophy. You're just going to end up typing make clean a lot otherwise and recompiling your entire code every time. But if you don't want to do that, the right way to do it is to specify your dependencies correctly. Okay, so now I'm going to play the same game again. I'm going to change this to expect an integer variable instead of a real. But then when I type make, something didn't work there. So, oh yeah, I get a type mismatch. That's correct. Sorry. So that's the correct behavior. It says something's changed in area, and therefore you have to compile area first, but you also have to recompile maths, and therefore I get an error, which is the error that I expected. So again, it's this philosophy of programming. What you want to happen is that the compiler finds your problems for you. You don't want to have to spend ages trying to figure out why the area of your circle came out to be 0 accidentally. What you would like is the compiler to tell you on line 8, column 52 of the file called maths.f90, there was a problem. So let the compiler do the work for you is the lesson. There's a little bit in the notes which I'm not going to go over about how to get the dependencies done for you. So for example, I'll just say briefly, so Fortran has this -m flag that you can use on maths.f90, for example. Sorry, yes. So we still, let me just fix this error. So we get to real intent in. Sorry, make clean and make. So Fortran, you can use this -m flag to give you the line that you should put into your Makefile. So it says maths.o should depend on maths.f90, which should depend on geometry.mod. But that has the same effect as what I just typed, which is simply making my maths.o depend on my area.o. The other advantage of properly specifying your dependencies is if you have a really, really big code, then you can compile the code in parallel. So for example, you can compile all the modules independently, and it will know how to do them in the correct order if you've specified your dependencies properly. So I just want to give you an example of this. I'm going to go to one of my big codes, which is called Splash, for example. And it's the same kind of code. I've got a lot of directories here, and there's a directory called source, which has got all my .f90 files in it. But if I want to compile this code, it's exactly the same thing as what you've done with your very small code. I simply type make. And, well, I'm going to type make clean to clean it up and show you how to compile a code from scratch. So it's a single line, make, but you can see I've got a lot of Fortran files here, and it's compiling them all in a single command. So it's just exactly the same as the small make file you've typed. All right, so that's how you assemble your Fortran into a... so you can imagine that you can have as many modules as you like, and you can compile them all into a single code just with this simple little script called a Makefile.